I just want to take a couple minutes to show you how to analyze a data set like this using scatter plots and using a technique called regression. So here's a data set that I recently pulled off of Zillow. So I just looked at the different houses that have been sold recently in my neighborhood. I wrote down the size of each house and the price. All the houses were very expensive, like well over $100,000. So I just made the prices in thousands of dollars, just knocked out the last three numbers essentially. All right, so let me take this data set. I imagine that larger homes are going to be more expensive, but it's hard to visualize that. So the best way to do that, I think, is a scatter plot. So let's copy this data set. So I just highlighted it, press Control C, and I'm going to bring this into Desmos and press Control V. So two things you might notice happened. One of them, it displayed all these points over here. Each point represents a different house that was sold. So this point right here is a house that was 3,489 square feet and sold for about $610,000. So yeah, you can see here that larger homes seem to be more expensive, smaller homes tend to be a little bit cheaper. It also inputted this table over here. So this table represents all these points over here. You don't have to use Excel to put in a table. You could always just type in the table directly into Desmos by clicking on the plus symbol and then selecting the table option. So whenever you have a table in Desmos, the first column is going to be called X1, second column is Y1, or if you did multiple tables, the next table would be X2, Y2, then X3, Y3, etc. So we want to fit some kind of relationship between these. If I want to do a linear relationship, we know the equation of a straight line is y equals mx plus b. But instead of y equals mx plus b, my y variable is called y1, so I would type in y1, and I just do this in the next box. Instead of equal, since I wanted to fit a model, I'm going to do this, I guess it's called the tilde, that's just a squiggle in the upper left corner of your keyboard. So y1 tilde m, our x variable is called x1, so I'll just type in x1. It automatically makes a subscript plus b. So there you go. So our estimate for the slope is 0.1679, and our estimate for the y-intercept is 49.647, etc. These numbers down here aren't super important to us right now, unless you're in a statistics class. But in a statistics class, R squared is basically how good of a model this is. The closer it is to 1, the better the model. You do have to be a little careful of this when you're dealing with multiple variables, but for the most part, the larger, the better. R is the strength of the linear relationship, which is only really useful when you're dealing with straight lines. Okay, so we can use this regression technique to model things that aren't straight lines, which is really cool. You can do that by just adding in extra terms. So like I can just, let's change this to A. Let's call this squared. And you see now that I fit a quadratic model. I can do these automatically as well. So linear models, quadratic, cubic, exponential, logarithmic, logistic, really a lot of different models I can do automatically using Desmos. So if I go up here, it automatically puts in a regression. This is the linear regression we saw before, and these are the same numbers we saw before. Quadratic, you see it gives the same numbers. It'll also quickly do cubic and quartic and exponential, etc. All these really cool things. When you're doing exponential, make sure you put it in log mode. Either mode is fine. It's just if you want to get the question right in the homework, make sure you do log mode. All right, so that's basically it. Let me just show you one more quick thing with the homework. So let's delete all of this. All right, so this is a homework question, or at least it is for this particular semester, on an extra credit assignment. And it asks us to fit this exponential, or rather, sorry, it asks us to fit a logistic model to this data set using this form, where our y variable, which they call n of t, is equal to c divided by 1 plus a e to the negative bt. Whenever you see these boxes here, that means we can copy the data set. So I'm going to do that. I press Control C to copy, pasted it in, and I pasted in my data set. The zoom is a little bit off. Let's just kind of default to the normal zoom. There we go. So here's my model. I want to fit a logistic model, and one of the options is down here to fit a logistic regression. However, this form doesn't match the form it asks for in the homework. If you look in the homework, it says to fit it where there's a number in front of the E. You can do this using algebra. If you just did e to the 5.02415 power, it would give you the coefficient in front. But if you didn't want to do that algebra, you can just tell Desmos to fit this model, kind of like what we did at the beginning. So I'll say y1 tilde. So I want c divided by 1 plus a e to the negative bt. So let's do that. So c divided by 1 plus a e to the negative b, and instead of t, t is just our x variable, and our x variable is x1. So I'm just going to type in x1, and look at it, just fit that logistic model. That looks really pretty good, honestly. And these are the numbers you'd fill in for the homework. That's really about it. If you were asked to fit an exponential model for the homework, right, same idea. You would just do like a e to the like k, instead of t would be x1. Make sure you don't pick the same letters you picked before. And again, make sure you pick log mode, and that's how you do an exponential model if it asked for that. All right, I think that's really about all you need to know with regression. Have fun exploring. Again, as soon as you get the data set in, you can just use those. You can just use this option up here to quickly fit models to the data. And as always, let me know if you have any questions.